Good evening, friends. Since we have discussed, quite a lot about regression and little bit of the concepts which are involved in regression. Now, I think I would like to go ahead and raise certain questions so that you can think about yourself before I can proceed further with my next topic. Now, first and foremost is that think about it. How many dependent variables will be there in our regression, in the linear equation? That's what I would use the word. And think about it again. Then how many independent variables will be there in our equation? Now, trust me, I also raised some of these questions very naively because I did not understand, and raising the questions, trying to understand them, why is what you require it. And once you have understood the basics, trust me, learning the higher concepts becomes much more easier. If you haven't understood the basic, you cannot understand the higher ones. You will be just be asking the question, okay, kindly help me out, and then they will be helping you manipulating your data, and then you have got it. No, don't do that. Try to understand and go further. How many independent variables will be there in the equation? How many errors will be present in the formula? Like in the formula I have given you only one e. Does that mean that there is one error, or you can have as many errors as you can? Think about it. Can there be multiple slopes or just one slope? Can there be multiple intercepts or just one intercept? These are certain things that you need to raise the questions when you are if you are learning and you are trying to be a very serious student about regression. Let's proceed further. Now, formula that I have given to you, it is called as simple linear regression. Now the question arises, why linear? That was again my question was that only. Once I saw, I said, okay, fine, this is the equation you have given to me. And then the moment I was given, they told me that, Ramni, remember that this is the formula and this is what depicts simple linear regression. My next question is, why linear? Why it cannot be dual regression or something else? So the quadratic regression, can I get, these are the questions that you need to raise in order to understand certain things. So here the first question arises, why linear? So from here we jumped into this one. There is exactly one independent variable in the equation. Now what does that mean? It means that if you look at the equation that we have got over there, there was just one independent variable. So they say that if when you are trying to draw that line, okay, then they said, okay, this is your variable, you have just got one variable. Now literally I drew that one to understand how that linear curve, whether it is a straight line or a curve, again we will have to think about it. When you are drawing it, try to understand. And this is the best part in Neeraj's workshop, that he gives you the data, okay, randomly he picks up, and then he says, can you draw this and check it out all by yourself? So it's not that bookish knowledge that you are getting it here. You are experiencing, you're seeing with your own eyes, your brains are also working, and you are able to draw. And with that drawing, you're able to understand that yes, I have got this one independent variable which is there, and how it is changing the dependent variable continuously. So you can see that equation, and when we draw the line equation, it comes out to be y, which is my dependent variable, equals to mx plus c. So this becomes my linear equation wherein I have got just one variable. Now let's proceed further from this one. Now if I have understood, okay, what the linear equation is all about, remember I said that I'll be talking about the parameters. Now I was wondering, variables, fine, I have got the variable, then what it has to do with the parameters? Now that's my next question. So let's have a look and see. You have got the formula in front of you, right? In big letters, you can keep it right in front of your eyes. First one, let's start off, begin with the y, which is on the left hand side of equal to. Y is the variable that one is predicting. That means when I say usually what happens, how do you write down your equations? You say 2 plus 2 or 2 plus 3 equals to 5, right? Now here also it is the same thing. However, because this function has become, otherwise when you are working, this will be like 2 plus 3, so it will be beta 0 plus beta 1 x plus epsilon, that is my error, equals to y. So what is y is your dependent variable which you are predicting it. Remember that x is the variable which is used for making the prediction y. Now you will have to see how, what exactly is happening to x, okay? Or in that particular equation, if you are keeping that x, then see what exactly happens to y also side by side. Now this is the amazing part, when you can see with your own data and proceed further more and more. And this I was when I was learning, I couldn't, because in one class I had to learn about regression, and in the other class, my MA in the sense meta-analysis classes was taking place. Now there also, because I was focusing on variables, so in meta-analysis I was focusing on variables. In regression, it was the relationship between those variables was being, so you understood how the connectivity is coming in. So then I understood, okay, this is how the things are coming in. So what is x now? Coming back to our story, x is the variable that is being used for making the prediction about what? About y. So we are going the other way around. So I have got y, that is the one that I need to predict. Then from where am I going to make the predictions? Obviously from the given set of the variables. Now what are those variables? Those are the independent variables for us. Then beta 0, this is called as the intercept term, and remember that it is the prediction value that one gets when x becomes 0. So this is something which you will have to digest before I can go ahead with the practical example. There you can see what exactly, and we will see when I'll have those interactive graphics in front of you, you will see how the changes are also coming in. Similarly, beta 1 equals to slope term. Okay, now explains the change in y when there is a unit change in x. So the moment I start changing x, I can see that the change is coming in y also side by side. Otherwise it's impossible that yes, x is there's no change in x, however y is only changing. That cannot be possible at all. Then comes my favorite thing, error. Yes, this is called as the residual value. Number one. Number two, if you are working in the mathematical formula, you will see that this is the difference between the actual and the predicted value. So what is the actual value and what are the predictive values? We will see in the mathematical understanding of it. Now, due to C.P. Gupta sir, I came to know that errors, we can call them as residual values. These are also called as the noise errors which are present. They create a lot of noise in the data. So like children who are there in front of us, some of them really create a lot of noise, the same thing. Or when you are stuck up in the traffic jam, you will see that a lot of noise is there. Or if you are in a populated city where a lot of people are there, you can feel that noise. The same thing he talks about it as noise, and he even calls it as a disturbance in the data. Now I literally started laughing when he was using these words, noise, disturbance, error. Then I was thinking, what he said is absolutely right. And later on, why these errors are so important, the noisy one, disturbance ones, and how they are going to help you out to make further predictions in the field of finance, accounting, I would say investments, projects, or even going further in the markets. How these variables, errors are going to help you out is really amazing, because now is the era where we're talking about the big data. So gone is a traditional data analysis approaches. We are entered into the contemporary ones where we need to focus more on these noisy variables or errors which are present in front of us. It is also called as an error, irreducible error, or and remember that they always tell us about the uncertain future. So I every day when we discover errors in our own life, I keep laughing and I say, okay, welcome error too, welcome error, welcome error. So you can nicely welcome in your own life also, side by side. And the last one that you have to remember is that one cannot eliminate the errors. So majority of the time, some of the research scholars, they come and show the data that or the entire output that they have got in AMOS or PLS, smart PLS, or even the other things that they are taking care in EViews or SPSS. Once they come and they say, I've got these errors, should I remove them? I just look at them. I said, why should you remove, and who asked you to delete them? Now, I really get shocked when someone tells me, okay, you delete them. I say, why should I delete them? First of all, let it be there. You cannot delete the data. You cannot simply remove them. That's why we say you cannot eliminate the errors. They are going to be there. However, one may reduce it. How you're going to reduce it, how this is going, and that's why in two different colors. That's why I chose that my PPT, when I'm discussing about regression, has to be in this orangish red color, which is my favorite color. It has to be present in that. And eliminate, I'm highlighting it by yellow color, and reduce in the orange color. Okay, because this is very important, and we will see we are not going to eliminate any of our errors. Okay, we just have to keep them, and we will see how to reduce them. And through how it is going to be reduced is also, there is a trick behind it, and we will see those tricks also. So this is how you're going to understand some of the things which are present. And let me move further, and we will so you have understood the parameters that we have got in the linear regression. Remember these things, and let's come up with yet another video where I'm going to talk more about the regression. Thanks and take care. Bye.